Task 2, Chart with website using RAG pipeline. The goal is to implement a RAG pipeline that allows users to interact with structured and unstructured data extracted from the websites. The system will crawl, scrap and store website content and convert into embeddings and store it in a vector database. Users can query the system for information and receive accurate context-rich responses generated by a selected LLM. This functional requirements data injection, query handling, response generation. They give the example websites links: U Chicago, Washington, Stanford, and Edu. For this, I have used the Jupyter Notebook for the code. This is the Python script. It implements a system that combines the web scraping, text segmentation, semantic embeddings, bias-based vector search, and a questioning answering model. Its goal to scrap content from given URLs, process it into an easily searchable from using embeddings, and answer user queries based on the scrapped data. First, I have imported the necessary libraries. These requests and beautiful soap are used for web scraping to fetch and parse web page contents. And the sentence transformers is to generate embeddings, vector representations of text for semantic search. This FAS library for efficient similarity search on large scale vector embeddings. NumPy for numerical computations such as arrays matrices. This transformers import pipeline is used for providing the questioning and answering pipeline. First, we are initializing the Hugging Face pipeline, which answers the questions based on a provided context. Next, this is a transformer model is used to generate a 384 dimensional embeddings for textual content. For scrapping the website content, it fetches the HTML content of a URL using requests and this code and extract the textual content from the paragraph tags using the beautiful soap. And this code is used for splits long text into smaller chunks of max chunk size. Default it has 500 to ensure efficient embedding and context processing. Here it initializes the FIAS index for this code. It initializes the FIAS index to store 384 dimensional embeddings. And it loops over the list of URLs and scraps the content from the website, segments the content into chunks, and it encodes each chunk using the embedding model, adds embeddings to a FIAS index along the metadata like URL, chunk ID, and text. And this is used for this code is used for encodes the user query into a vector using the embedding model, searches the FIAS index to find the top 5 similar chunks based on the cosine similarity. Here it combines the retrieved chunks into a single context string to pass to the question and answer model. For this, passes the query and context to the question and answer model pipeline, which generates the answer. It defines the list of URLs to scrap, calls the storing embeddings to scrap embedded and store the content in files. Here enters an interactive loop where the user can input questions, queries the FIAS index, and question and answer pipeline for answers. Now I am executing this code. The workflow of this code is to first it fetches the content from the URLs and then it breaks the text into chunks for efficient processing and it generates the vector embeddings for each chunk and it stores the embeddings in a fast library for fast similarity search and process user queries and find relevant chunks and answer question using a question and answer model. And based on the user request, top five similarity searches from that chunks, it will give us the output. Here it scraps the Stanford, Education, and Washington, but it's failed to fetch the U Chicago website because it stores the status code for not 3. Because of the high security, it doesn't scrap the website due to the high securities and it's a server error. We have to enter the query. First, we will enter research in Stanford. Effective clinical therapies on that it is researching. It, see here, it's generating the query embedding, searching in the files, querying using the Hugging Face question and answer model. It's giving the responses. Visitors for the websites. 196. Next, student life, student accounts. No, I'm executing exit. It's exited the model like this. It works. It extracts the content from it web scraps from these URLs and it stores uh, and it separates the large chunks into the smaller chunks and it stores the embeddings using the FAS index. It searches it and it queries using the Hugging Face and query model. Like it like this code works. Thank you.